I had spent the entire week working on my latest science project, learning about simple tools that are used to make work easier. Scientists actually just call them simple machines. Well, anyway, I needed a break. The funny thing was that while I was relaxing, I realized that there were simple machines all around me. But before I show some of them to you, we need to understand a few basic things. So here we go. When I say the word machine, what do you think of? Maybe a giant crane? Or a car's engine? Or maybe even a mixer that's used to make cookies? Well, you're right. These are all machines. We use machines to make work easier. But remember, I said we're going to talk about simple machines today, right? What's the difference? A simple machine is, well, simple. It has very few moving parts, or no moving parts at all. You know, I think you're in for a surprise, because as we look at them, you'll realize that you've seen and used most simple machines many times. But before we look at some examples of simple machines, we need to talk a little bit about force. A force can be a push, like when these football players push against each other, or when I push this ball down the alley. I'm even using a pushing force when I type stuff into my computer. A force can also be a pull, like these powerful jeeps in a giant tug-of-war. That's real pulling force. And when I hoist this sail, same idea, another pulling force. I gotta tell you, this isn't easy. When we use a force to move something, we are doing work. Pushing, pulling, and lifting are common forms of work. Think back to every example we've just looked at, and you'll see that when work is being done, something always moves. Today we will look at 6 simple machines: the lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. They all help us to use less force to move things. Simple machines have been around for a long time. I mean, think about it. Ancient people who needed to move something heavy, like a rock, didn't have many choices. They had no bulldozers or trucks. It was a problem. But somewhere along the line, they had an idea. They discovered that by putting a stick under the big rock and leaning it on a smaller rock, they could lift the big rock. They didn't know it, but they had just used a simple machine, one that we call a lever. They could now move big rocks. Life was good. There are many kinds of levers, but they all work by leaning one thing on another to move something else. Like in our rock example, the stick was leaning on the small rock. The stick is the lever, and the small rock is called the fulcrum. By resting our lever on the fulcrum and pushing down on one end of the lever, we can lift the rock at the other end with less force. Every lever needs a fulcrum, something to lean against. In this experiment, we'll use a seesaw to learn how a lever can make work easier. I'll bet you probably never thought of a seesaw as a simple machine. I admit it looks simple, but it can teach you a lot about lifting things that are at least as big and heavy as you are. Along with the seesaw, you'll need a stool and a friend who weighs about as much as you. Now, the work we'll be doing is lifting your friend. First, carefully try and lift her off the stool. Maybe you can do it, but you've got to admit it's a lot of work. Can you think of a way to use this simple machine to make that task easier? That's where the seesaw comes in. A seesaw is a lever, and it's made up of two parts: the board that you sit on and the bar in the middle. This middle bar is the fulcrum. It is what the board leans against. As everyone knows, if you and a friend sit on the seesaw, you will be pretty much in balance, if you both weigh about the same. But let's try something different. Have your friend sit on one side of the seesaw, but close to the bar, not on the seat. Now, go to the other end and see if you can pull it down to you, or even to the ground. Voila! With very little effort, you are able to lift your friend into the air. You don't even have to put all your weight on the seesaw to do it. That's because the seesaw is acting as a lever. It's making the work easier. Now let's try it another way. Have your friend sit at the end of the seesaw, on the seat. Now move closer to the middle and try to pull your end down. What has happened? Same friend, same seesaw. Why is it so much harder? The key is how far each of you is from the fulcrum. When you are farther from the fulcrum than your friend, like the first time we tried to lift her, the work is easier. When your friend is farther from the fulcrum, like the second time, the work is harder. And when you are both the same distance from the fulcrum, you're balanced. I guess you could say the seesaw is a simple but terrific machine. It's really a great example of how a lever can make lifting easier. Levers come in all different shapes and sizes. A hammer can be a lever. The curved claw end can be used to pull a nail out of a board, like so. Do you think you could do this without using a simple machine? Way too much work. Let's look at that again. Remember, we said that every lever needs a fulcrum. Here, the hammer leans against the board. The board is the fulcrum. Apply force to one end of the hammer, and out comes the nail at the other end. When you think of machines, you probably think of big steel contraptions, right? But it might surprise you to learn that your body is actually a machine too. Think about it. When you throw a ball, your arm is working as a lever, turning around your shoulder and elbow to let you throw the ball with more force. And when you swing a bat, the bat is really a lever too. It's the same in hockey. A hockey player uses the stick as a lever to swing at the puck. Our bodies are full of levers: knees, elbows, shoulders, fingers, and they all help make work easier for us every day. Whether you're a tricycle rider, bicycle rider, rollerblader, motorcycle racer traveling at over 200 kilometers an hour, or just me trying to carry a really heavy suitcase across a giant airport, wheels can make what you're doing easier. I don't think any tool has changed the way people live more than the invention of the simple machine called the wheel and axle. A wheel and axle is really another type of lever. The round wheel is connected to a round post called the axle. Turn the wheel, and the axle goes along for the ride. And that means anything resting on top of the axle gets a ride too. The wheel turns on the axle the way the lever tilts on the fulcrum. Yep, if you look around, you can see examples of the wheel and axle everywhere. Take something as simple as a doorknob. The knob is the wheel, and the post that goes through the door is the axle. When you turn the knob, the post turns easily. It seems simple, but try turning the post without the knob attached. Here's a great example of another simple machine, called a pulley. It helps me raise this heavy sail without having to climb way up high to do it. A pulley is a special wheel with cord wrapped around it. When the rope is pulled, the wheel can turn in either direction. By pulling on one end of the rope, you can lift an object on the other end. The neat thing is that each wheel of a pulley makes the work easier. So with several wheels, people can lift things that they could never lift with just their hands. Pulleys are even used in giant cranes to lift very heavy loads high in the air. Just think how hard it would be to lift these huge containers by hand. Pulleys can definitely make work easier. Okay, back to the little pushing force performed by my fingers, and a quick review. Forces play an important part in understanding simple machines. A force can be a push or a pull. When we use force to move an object, we are doing work. We use simple machines in our lives to make work easier. So far, we've looked at 3 different simple machines. The lever, which always leans against a point called a fulcrum. The wheel and axle, which is a large wheel turning around a smaller wheel. The wheel and axle is really a form of lever, except that it turns all the way around in a circle. And the pulley, which is a wheel with a rope or cord around it. By pulling on one end of the rope, we can lift an object on the other end. I came across this gardener when I was working on my science project. Boy, was he struggling. That mower was heavy. This poor guy was tired and frustrated. Then these really smart kids helped him create a ramp with these wooden planks. A ramp is an example of a simple machine called an inclined plane. It's really just a flat surface set at an angle. Look how much easier the work is when something can be pushed up and across a ramp instead of being lifted straight up in the air. It takes much less force to get the job done. You're looking at one happy gardener, and you've seen how a simple machine can turn sweating into smiling. We saw how using a ramp makes it easier to lift things. But what about when you need to lift your body? Like if I want to get to the top of this lighthouse. If I had to climb straight up, it would be very hard. Luckily, I can use another form of ramp. Stairs. That's right. Stairs are also a form of inclined plane that make it easier to get where you are going one step at a time. Another simple machine that uses flat surfaces is the wedge. It's often used to split things apart. If you use a little imagination, you can see that a wedge is really 2 small ramps, or inclined planes, that form a point. A wedge uses this point to make the work easier. The front of a boat is shaped like a wedge. It uses 2 flat surfaces to push through the water easily, kind of like a wedge pushes through 2 pieces of wood. If a wedge is very, very thin, we might say that it is sharp. In fact, a knife is a very thin wedge that's used to split things apart by cutting. Sharp knives make the work of cutting things easier, but be careful, they can cut you too. The last simple machine we'll talk about is the screw. Just like we saw that the wedge is really 2 inclined planes, when we look really closely at a screw, we can see that it's really 1 long inclined plane wrapped around the screw many times. Think of climbing a mountain. If you were to climb straight up the side of the mountain, it's very steep and it takes a lot of effort. If you take a winding path, it's not so steep. The trade-off is that you would have to walk a longer way, but each step takes much less effort. Just like the winding path on the mountain makes it easier to climb, the winding inclined plane on a screw makes it easier to turn. So let's do another quick review. We saw 3 more simple machines that help make work easier. The inclined plane, a smooth flat surface like a ramp that allows us to lift things using very little force. The wedge, which is really 2 inclined planes that meet in a point. And the screw, which is really an inclined plane wrapped around and around. Okay, let's do a little quiz to see what you know about simple machines. Question 1. What does a simple machine make easier? Answer: work. Question 2. A push or pull that moves an object is called what? Answer: force. Question 3. A seesaw is an example of what kind of simple machine? Answer: a lever. Question 4. What do we call the round post that a wheel turns around? Answer: an axle. And question 5. What kind of simple machine is a ramp? Answer: an inclined plane. Well, that's our quiz. How'd you do? I think you can see that simple machines really are pretty simple. We've seen a bunch of simple machines today, and we found some of them right here on this boat. Well, here's the last thing I want you to remember about simple machines. They're often used together as a team to make work easier. Think about a bicycle, for example. Of course, we know it has wheels and axles. It also uses levers, like in the handlebars and the brakes. The chain is really a form of a pulley. And some bikes even have a fancy system of gears that can make pedaling much easier. A machine, like a bike, that uses 2 or more simple machines together is called a compound machine. Look around you. See how many compound machines you can find. This giant crane uses levers and pulleys to lift very heavy loads. It is definitely a compound machine. But compound machines don't have to be big or complicated. A perfect example is a normal pair of scissors. It works as 2 levers, with the fulcrum in the center, applying force when you squeeze. And it works as 2 wedges, using the sharp edges to cut. I'd say this was a pretty full day. I think you've seen that simple machines are pretty important to our lives. Take a minute, maybe before you go to sleep tonight, and try to imagine getting through just one day without the help of simple machines. I'd say it's almost impossible. Happy sailing! See ya!